In this video, we are going to discuss how to calculate area of polygons in the coordinate plane. Area is how much space is inside of a shape, and units are always squared. Some key formulas we'll see in this video. Area of a parallelogram, rectangle, or square is area equals base times height, or length times width. And area of a triangle is 1/2 base times height. Sometimes those formulas are not as simple to apply because we might not be able to quickly figure out what the base or the height is. So on those problems, a great strategy is something called the box it in method. This is where you create a rectangle around the given shape and find its area. Then you'd find the area of the surrounding triangles and subtract from the rectangle's area. So in this video, we'll look at a couple quick examples and then we'll look at a couple using the box it in method. All right, let's get started with example 1. In example 1, we are asked to find the area of the rectangle. I can see in this picture that the base and the height are easily counted. The base is going to have a measure of 6 units. The height has a measure of 3 units. And area is base times height of a rectangle. So we have 6 times 3, or 18 units squared. Okay, remember, anytime we are calculating area, we are always talking about units squared. Moving on to number 2. Find the area of the right triangle. So area of a triangle is 1/2 base times height. I can see that the base in this triangle is 7 and the height is 2. So I'm going to substitute those values into the area formula. And I get that this triangle has an area of 7 units squared. All right, moving on to example 3. Find the area of rectangle ABCD, and it gives us the coordinates. So I have already gone ahead and plotted these 4 coordinates on the coordinate plane. And we saw that on the first example, that area of a rectangle we could use base times height. The issue with this picture is that I cannot quickly count the boxes and figure out what the length and the width are, or the measure of the base and the height, because they are diagonal line segments. Anytime segments are horizontal or vertical, we can quickly count. Here I would have to use the distance formula if I wanted to do that, or we're going to talk about this other strategy called the box it in method. So you'd first have your original shape plotted, which I already have here. And then basically what we're going to do, okay, so I'm going to use a different color to show you, is we're going to draw a box or a rectangle that surrounds this given picture. And we want this rectangle to go right through the vertices. So I went through D. I'm going to go through C. I'm going to go up through B. And then I'm going to connect. Okay. When I do that, I basically have created some surrounding triangles in here. So I'm going to highlight them so you guys can see. So our strategy is this. We're going to find the area of the big rectangle. We're going to find the area of these surrounding triangles, and I'm going to number them just so we can keep track of which one's which. Doesn't matter which one you number or what. And then we're going to subtract those values. It's basically turning this into a shaded area problem. We find the area of the rectangle. We find the area of the surrounding triangles. When we subtract that, we'll have the area of rectangle ABCD. So the reason this strategy works nice is because when we draw this box or rectangle, I get values that I could just count. So I can see the base of this rectangle has a value of 9. And I can see the height has a value of 6. So off to the side here, I'm going to calculate the area of my rectangle. Base times height is 9 times 6. Or 54. Now what I'm going to do is I'm going to calculate the area of triangle 1, triangle 2, triangle 3, and triangle 4. For triangle 1, the triangle has a base of 1. It has a height of 4, and therefore its area is 2. In triangle 2, the dimensions are 1/2, 8 times 2, for an area of 8. Triangle 3, 1/2, base is 1, the height is 4, so the area is 2. And triangle 4 is 1/2, 8 times 2, an area of 8. So if I want the area of rectangle ABCD, we start with 54 and we're going to subtract out all of the surrounding areas. And that's going to give us a total area of 34 units squared. All right, we're going to try that same process again on number 4, except now we're finding the area of triangle ABC. Again, when I look at this, I can't quickly count the boxes and figure out what the base and the height are. So I'm going to go into my picture on my graph here, and I'm going to start boxing in the given triangle. Highlighting or coloring in, shading the surrounding triangles is not necessary, but it might help you better understand why we're finding the area of the box, why we're finding the area of the surrounding triangles, and really ultimately why we end up subtracting those. I'm going to once again number my triangles, 1, 2, 3. When I count and find the dimensions of the given rectangle, okay, I can see that the base of this rectangle is 12, and I can see that the height is 9. All right, so to start off, once we have our measurements in our box, we are going to calculate the area of that surrounding box or rectangle. So since we found the measurements are 12 by 9, the area of the rectangle is base times height, 12 times 9, or 108. Then we're going to find the area of triangle 1. That's 1/2 of 6 times 9. Okay, counting the base and the height. And that's going to give us 27. The area of triangle 2, 1/2, 12 times 5, which is 30. The area of triangle 3, 1/2 of 6 times 4, which is 12. So to finally get the area of triangle ABC, what we were asked for in this problem, we're going to start off with the area of the box. We're going to subtract all of the surrounding triangles areas. So 108 minus 27 minus 30 minus 12, and we get our answer of 39 units squared. Hopefully this video helped you understand how to calculate the area of polygons in the coordinate plane.